Hello, and welcome to the video for lesson number 3 on finding the area and the arc length of a sector. So whenever we're dealing with sectors, remember we're talking about portions of a circle. So we have to be able to figure out what the portion of the circle is before we can determine the area or the arc length or part of the circumference of that circle. So let's take a look at number 1. So number 1 says an ant crawling around the perimeter of a circle whose radius is 2 feet through a central angle of 72 degrees. What is the distance to the nearest inch that the ant has crawled? So we have this part of a circle where the ant is crawling around and it's creating a central angle of 72 degrees. It says the radius is 2 feet, so we have a 2-foot radius. So when we're finding the arc length, we use S for the symbol. It has an angle of 72, which is over 360. Times, now in this question, we're not considering the area of the sector. We want to know the distance on the outside or the crust of the slice of pizza we said in class. So that's circumference. So we're going to say 2 pi times the radius, which we said was 2. Notice this question says nearest inch, so when I plug this in my calculator, I'm going to plug in pi. I'm not going to put this in terms of pi. So if I do 72 over 360 times pi times 2 times 2, we get 2.51, which rounds to 3 inches. Because it does say nearest inch. So 2.5 rounds up to 3. Let's take a look at 2. 2 says a circle has a radius of 18 feet. Determine the area and the arc length of a sector if the central angle is 36 degrees. So just asking us to define 2 things. So let's just sketch our sector so we see what it looks like. So we have a central angle of 36 and we have a radius of 18. So let's do area first since we just did arc length. So the area of the sector. So to find the area, we have to take the central angle of 36 degrees. So we're going to have 36 degrees over 360 times pi and the radius squared. Now, this question doesn't ask us to round or do anything like that. So I'm going to find this answer in terms of pi. So if I do 36 divided by 360 and multiply that by 18 squared, that gives me 32.4 pi. That's in terms of pi. If this question asks us to round it to, say, the nearest tenth, we'd then multiply that by pi, and that would give us 101.8. Again, it would depend on how the question was worded. To find the arc length, we're going to use the same fraction, 36 over 360, but we're going to multiply it by 2 pi times 18. Just like we did for the area, let's first find this in terms of pi. So if I do 36 over 360 times 2 times 18, I get 3.6 pi. If I find this rounded to the nearest tenth, I get 11.3. So again, depending on how they asked to answer the question is how we would do it. For the third question, this one's kind of tough because in this question, they don't tell you the central angle. They tell you the area. So because they tell you the area, when we plug into the formula, the area is 12 pi. The central angle we don't know, so that's going to remain theta, or the variable. And we know the radius is 6. So now I want to get it so that the theta is by itself. So the first thing I'm going to do is square the 6, which gives this as 36 pi. Since I want to get rid of the 36 pi, move it to the other side, I'm going to divide it away. Those two numbers cancel. If I divide 12 pi by 36 pi in my calculator, I get 0.3 repeating. If I hit math, enter, enter, it becomes 1/3. Or if I just know it's 1/3, that would help a little bit. And then I have two fractions equal to each other. And you might be saying, I don't know what to do there, but you do, because anytime we see two fractions equal to each other, we always cross multiply. That's an algebra skill. So then we have 3 theta is equal to 360. If you don't like theta, just use x, it's fine. Divide both sides by 3, and we get theta is equal to 120. So angle AOC is 120 degrees. Hopefully this video helped. Questions like number 3 could even pop up on that quiz that you're going to get this week. And best of luck with your homework. See you all tomorrow.